Okay, so the next thing that we need to add to our model is basically the bulking logic. So if I go back to the problem description, we know that customers bulk if there are 6 people in the system. So when a new customer arrives, if there are 6 people in the system, anywhere in the system, in any of the stages, the customer will basically exit the system without entering the first station. And we're also interested in two new performance metrics: the percentage of customers that bulk and the average time in system per customer type. So we're going to modify our model to account for these new extensions. So if I go back to my Simio model, what I really need to do is to basically tell my source object, or somewhere here in my source object before the first station, I would like to make a decision. So when an entity arrives, I need to basically check the number in the system, the number of entities, customers in the system, and then if it's greater than 5, or if I have 6 customers in the system, my entity should leave the system. So what I basically need is a sync object here, and I'm going to call it bulk. And this is basically where the bulking customers exit my model. And I'm going to connect my source object to my bulk sync. Now remember, this is a logic that is not automatically, or is not built into the logic for the source object. So if you basically know how the source object in Simio works, you know that the bulking logic is not incorporated into its default properties or default behavior. So what we need to do is to modify the built-in behavior or built-in characteristics of the source object. And we already know that we can do this in Simio using add-on processes, just like what we did for basically the logic to have different customer types and changing the look of the or symbol of the entities. So what I'm going to do here is to basically use the same add-on process that I have, and I would like to add more steps to it to implement the bulking logic. So what I need is that regardless of the type of the entity that is created, or the type of entity that enters the output node of this sync, I would like to make a decision based on the number of systems, a number of entities in the system. So what I really need is a decide step after I perform all of these steps, and since it's regardless of the entity type, I'm just going to connect the end of this branch after my assign to the new decide step that I've added. So now for cold customers, I perform these steps with a probability of 30% or 0.3. I change the processing time, or assign a processing time of 0 on the oven, and I change its symbol to my second index, or to my second symbol in the symbol list. For hot customers, I sample the processing time on the oven for each customer. And then regardless of the entity type, I would like to make this bulking decision. Now this time, the decision that I'm going to make is based on a condition. So unlike the first decide step that we made a decision, a probability-based decision, this time we're going to make a condition-based decision. And our condition is, it has to do something with the number in system, and specifically we want to make a decision if the number in system is 6 or is greater than 5. So what I need is the instantaneous number in system. So what I need is customer dot population dot number in system. And specifically, I want customers to bulk if I have more than 5 customers in the system. That means if I have 6 customers in the system. Alternatively, you can put greater than or equal to 6, or just equal to 6. So I'm just going to use greater than 5. So now, if this condition is true, if I have more than 5 entities or customers in the system, my token will take the true branch of my decide, and this is where I need to implement the bulking logic. And since I've already created this sync object instance for my bulks, and the connector from the output node of the source to the input node of this sync, I can basically use the set node step to set the destination node of these bulkers. So what I would like it to be, I would like these customers to have a destination type, a specific destination type, and specifically it should be input of the bulk. So there it is, input at bulk. So now what I do is, if this condition is true, if I have more than 5 customers in the system, I set the destination node of the entity to input at bulk. For the rest of the entities, if the entity does not bulk, I would like the destination to be input at bread and meat. Now, before I verify that our bulking logic is actually working, I would like to show you guys an alternative approach to change the symbol of the entities. So this time, I would like the entities that enter the bulk sync to change symbols. Now, this time, of course, I can again define an add-on process for the entities that enter the sync. So either an add-on process trigger when entities enter the sync object, or I can click on the sync itself and again define an add-on process on entered. And then use basically the same logic that I have defined here, and use an assign step to change the symbol. After, of course, I have defined a third symbol in my symbol list. But this time I'm going to show you guys an alternative approach to do this, and that's using state assignment. So when you click on some of the objects in Simio, you will see that one of the properties is, let me click on the sync, one of the properties is state assignments. So if you expand this, you will see that you will have different options to change this, some model or entity or model state variables using those state assignments without having to define an add-on process. So what I'm going to do, I'm going to define a third symbol for my bulkers. So I'm going to add a new symbol, select my new symbol, which has an index of 2, and I'm going to select, let's say, black for the bulkers. And this time, and I need to click on my model entity. Now this time what I would like to do is to use the state assignment to change the color or symbol of the bulkers. So now I go to state assignments, and on entering to the sync, I would like to change the model entity picture. So model entity picture, I would like to change it to index 2. Now this time I'm not going to use model entity dot picture plus 1 because both hot customers and cold customers may bulk. So I would like to make sure that my symbol becomes second index in my symbol list, which is my black color, as you can see here. So now what I'm going to do is to run my model in the interactive mode, and I'm going to set a breakpoint here so that any time that somebody bulks, I would like to first verify that I have 6 people in the system, and also verify that that customer actually changes color. And also note that this changing the symbol at the bulk really doesn't add anything to our model. I just wanted to show you guys an alternative way to basically use state assignments to change some of this state variables in your model. So now I'm going to run the model. So anytime that an entity enters the sync object, so right now the model has stopped, and I'm going to go to run and step, and now you can see that this entity changed color to black. However, there seems to be a problem with my bulking logic, because instead of bulking when I have 6 customers in the system, now I have 1, 2, 3, 4, 5 customers in my system. So this is exactly why we need to run our model and try to verify after we add a new feature to our model. So we sequentially add new features and verify our model. So now I should correct my bulking logic. And the reason this happened was that I set the bulking condition to a number in system greater than 5, and I didn't realize that when a new customer arrives, number in system will be 6. So my condition will be true, but the problem is that the sixth customer is actually the customer that is going to bulk. So what I need to do is to go back to my decide. So let me stop my model, click on my decide, and change this to 6. So now when a customer arrives and the number and there are 6 customers in the system, but technically I have 7 customers in my model because of that new customer that has just arrived. The new customer will bulk. So now I'm going to run my model again and see if the problem is solved. So it looks like this hot customer is going to bulk. So I'm going to click on step. It changes color, so my state assignment step is working. And also I have 1, 2, 3, 4, 5, 6 customers in my system, as you can see. And now I can run my model again, and basically I will repeat this process until I verify that my bulking logic is correct. So again, this entity bulks, it changes color, and I have 1, 2, 3, 4, 5, 6 entities in the system when it bulks. So now that we have implemented the bulking logic, let's go ahead and estimate the 2 performance measures. So we're specifically interested in the percentage of customers that bulk and average time in system, but this time per customer type, per hot and cold customers. So I would like to talk about the second metric real quick first. So I need to go back to my model, and I would like to show you the results of an interactive run that I have performed for 300 hours. And what I'm interested in is the time in system. And I'm interested in the average time in system in minutes. And as you can see, I can get the information about time in system from 3 objects in my model. So I can get the time in system for all customers, which is 6.5436 minutes. Time in system for those customers that entered the bulk sync, which is 0, of course. They bulk in 0 simulation time. And time in system for those customers that exit through the exit sync, which is 7.2529. And the reason this value is greater than this value is that in the first one that we get from the customer object, we basically include the bulkers, so we have some 0 values when we calculate the average time in system here. So that's why we see a smaller value than the one we get from the exit sync object. But as you can see, I don't get any information about time in system per customer type because I haven't implemented the logic to collect that statistic yet. So since I can get time in system from the sync object, what I would like to do, I would like to remove this exit sync and instead add 2 new syncs to my model. So I'm going to have 1 sync and 2 syncs here. So I'm going to call the first one cold sync and the second one hot sync. So I want cold customers to exit through my cold sync and hot customers to exit through the hot sync, so that I can get separate time and system statistics for each customer type. Now this time, of course, again, we can go ahead and define an add-on process that implements this logic of this routing logic that we are interested in. Alternatively, we can also use the link weight to make this decision, this routing decision. So this time I would like to show you guys this alternative approach. So now I'm going to click on my new connector here, and I would like to use a condition here for my selection weight. So I'm going to use model entity dot, and I know for cold customers the processing time on the oven, which is the state variable that I have defined, is 0. So now what Simio does is that whenever an entity is going to be routed out of the output node of the drink machine, if this condition is true, if the processing time on oven for that model entity is 0, then that entity will go to the cold sink. And I'm going to need to implement the alternative condition on the other sink. So this one will simply be equal, or the expression will be model entity dot processing time, this time a value that is non-zero. So now when I run my model, let me go ahead and set breakpoints here so I can verify that this is actually working. I can run my model, and whenever an entity leaves the system, I would like to verify that cold entities exit through the cold sink, hot entities exit through the hot sink. So this one is a cold customer that exits through the cold sink. The next customer is a hot customer, and it exits through the hot sink. And I keep running my model to verify that it's actually working. So I'm going to let you guys try this for a while, for a number of entities, just to make sure that everything is working correctly. So the last thing that we're going to do in this lab is to perform an experiment with this model. So this time, instead of going to the project home and create a new experiment, I will just basically duplicate the previous experiment that I performed with the earlier version of this model, just to save some time so that I don't have to set the run configurations. And I would like to rename this one to model with add-on processes, but this time with bulking. So now I'm going to have to add my responses that I need for my performance measures. So basically I need 3 responses. The first one is my percentage that bulk. So bulk percentage. And the expression for it will be basically the number of customers that bulk divided by the total number of customers that were created. So the number of customers that bulk, I can get that from the bulk sink. So I can go to my bulk sink and then input buffer number entered. And I would like to divide this value by the total number of entities that were created. So I can get that value from my source object. So I can go to my enter source object. Then it's output buffer, and then number entered. So now this gives me the proportion of customers that bulk, and if I actually multiply the whole thing by 100, I will get the percentage of bulkers. So I'm going to say OK. So that's my first performance metric. The second one is the time and system for cold customers. So I'm going to call it cold TIS. Cold TIS. And I know I can get this value from my cold sink. So I'm going to go to cold sink, time and system, average. And the last response that I need is time and system for hot customers. So hot TIS, and I can get this from my hot sink object. Again, time and system and average. So now I'm going to run my experiment, and since I copied my experiment, everything is set up. So I'm just going to click on run and wait until the model is run. So now my experiment is run, and you can see that almost 10% of my customers bulked, and for my cold customers, I am getting 0.117 hours for time and system, and for hot customers, I'm getting 0.122 hours. And of course, if you want to get these values in minutes, you can simply multiply the expression that you have for the 2 responses by 60, so that you can get the values in minutes. And of course, if you compare the results of this model with bulking with the earlier version of the model that did not implement bulking, you will see that your overall time in system for all customers, your overall number in system, and the utilizations have all decreased compared to the model that did not have bulking. And of course, that's because now you fewer people enter your system, so you expect that to happen. So this is kind of to again verify that your results make sense and actually are in line with your expectations.